Let's take a look at elastic potential energy example number 1. We have a spring of a known spring constant, which is 1,000 newtons per meter. It has a resting length of 32 centimeters. Some force comes along and pushes on this spring and compresses it to a final length of 19 centimeters. And the question is, how much elastic potential energy is stored in the spring once it's been compressed to that degree? So in order to figure this out, we just have to utilize the elastic potential energy equation, which is 1/2 K, spring constant, times the displacement of the spring from its rest position squared. So if we take a look at everything that we're given, we know the spring constant is 1,000 newtons per meter. To find the displacement of the spring, we will do the final length, or the final position, minus the initial, the final being 19 and the initial being 32. So I get negative 13 centimeters, which when I convert to meters is negative 0.13, the negative implying that it has been compressed as opposed to being stretched. Now that I have that information, I can simply plug that into the elastic potential energy equation, squaring only the displacement of the spring, and determine that, in fact, I have stored 8.45 joules of elastic potential energy.